Hello, my name is Tyson Fries, and this is my Python implementation of the board game Othello, but multiplayer using the socket module. I've started by running the server, and it's listening on 61530 for connections. So we'll go ahead and run those connections. And once we have two connections, the server will send the board to one of the players. And from here, we can go ahead and play a spot on the Othello board. The board is run using a two-dimensional array in the background and uses recursion to identify what is a valid move and which tiles to flip over when you play. So you see we played 4-6, and over here 4-6 is where we got played, and the 0 is flipped into a 1, just like you would expect in Othello. And so if we play over here, we can do 3-6, and we'll go ahead and send that information over to here. And we can see it represented well. If we play something that doesn't make any sense, like 1-1, we'll send the board back to the right person so that they can play a valid move. And you can keep playing like this until either the board is full and someone wins, or until you quit. So I'm going to walk you through the code. The board class is how the Othello board is implemented. And we won't get into it because it's relatively simple. The networking code is very similar between the server and the client. So we'll walk through the server, and then I'll talk about the small differences for the client. For the server, we start by extending the board class to include some server functionality. We want to know if the board has been sent yet, and we also want to know the IP address of each of the players, according to whether they're 0 or 1. And so we update that here, and we also include a way to get the display as a byte string so that we can send it over the wire. We start by implementing some constants, the host, the port, and then also a default selector, which we will use to monitor the different sockets. And then, of course, the Othello board. These two functions I'll explain as they get called. But before any of that, we configure a listening socket, which will listen on a port for incoming connections. And we set the blocking to false. That way, when we make calls to a socket, those calls will return instead of causing the whole program to hang. The problem with that is that we then lose the ability to monitor that socket. And so that's why we have the ability to register it with that default selector. We register the listening socket with data as none. That'll be important in a second. And the only events that we do with the listening socket is read. Obviously, you're not going to write data to the listening socket because all it does is listen. So if the game isn't over, we're going to get events from all of our sockets. And so at the beginning, that'll just be the listening socket. And we know that it's the listening socket because that data is none. And so if the data is none, then we're going to go ahead and process that new connection that the listening socket listened and heard. But only if we don't already have two people playing. If we have more than two people playing, we don't want to accept more connections. If the data isn't none, then we know that that is one of the clients, and we need to start processing that information. So if there's two people, we can start playing, and if the IP address is the IP address of the current player, then we're going to service their connection because it's one player and then the other, one at a time. So when we accept a new connection, it's very similar to creating the listening socket, except we include in the data an inbound byte string and an outbound byte string, and then obviously the IP address, and then also we specify that the read event and the write event are both allowable. They're both permissible. And then we register it and their IP address. When we service a connection, we look at the event mask on that socket. The event mask will tell us if reading is open or writing is open, if they're open to be doing. And so here, if the mask bitwise and event read is true, that means that we're able to read on that port. And same here, we're able to write on that port. And so if we can, then we're going to go ahead and receive that data. And we can, if this is the server, we'll parse out the integers from the message that was sent right here, 1, 1. We'll parse out those integers and try and play it. This is to close the connection if we're done receiving data. Here, if the board hasn't been sent yet, we'll go ahead and write that out and send it to the client. And that's the actual sending code is right here. But this is what makes sure that we don't send it more than once. Everything is very similar for the client except the way we send and receive data. Instead of sending the board and receiving that pair of where we want to play, we send the pair and receive the board, which you can see is written right here. Otherwise, it's very similar. And that's how it works.